Section 3.1, Introduction to Graphing. The flat surface on which we draw graphs is called a plane. To create a coordinate plane, we begin with a horizontal number line called the x-axis. Notice the x-axis in our drawing here. A vertical number line, the y-axis, intersects the x-axis at the origin. That's this point where the two axes intersect each other. The x and y axes are boundaries that separate the coordinate plane into four regions called quadrants. So we have the first quadrant, where both x and y are positive. We have the second quadrant, where x is negative and y is positive. We have the third quadrant, where both x and y are negative. And then we have the fourth quadrant, where x is positive and y is negative. So let's determine which quadrant these points are located in. So the point 3, 5. In an ordered pair, the first number is x. The second number represents y. So the first number tells you how far right or left to go, and the second number tells you how far up or down to go. We always start at the origin. So if you start at the origin and you go right 3 and up 5, you would be right 3, up 5, you would be right here. At that point right there. So you're in the first quadrant. You represent the quadrants with Roman numerals. So if you start at the origin and you go right 2 and then down 9, you would be somewhere in the fourth quadrant. If you start at the origin and you go left 25 and down 25, you're in the third quadrant. And if you start at the origin and you go left 6.7 and up 4.5, you will be in the second quadrant. But not all points are located exactly in a quadrant. Some points are located on an axis. So if you think about the number or the point 1000, you would start at the origin and you would go right 1000 units, and then you would go neither up nor down. You would stay right where you are. So you would fall, not in a quadrant, you would fall on the x-axis. That point is on the x-axis. Now point B here is 0, negative 5.6958. So the first number, remember, tells you right or left. You don't go right, you don't go left. You start at the origin, and then you go down 5.6958 units. So you will fall on the y-axis, not in any of the quadrants. Each point in the coordinate plane is represented by a pair of numbers called an ordered pair. Ordered pair. The first number in an ordered pair represents a horizontal distance and is called the x-coordinate. The second number in an ordered pair represents a vertical distance and it is called the y-coordinate. So let's plot the following points on the coordinate plane. So point A is 0, 0. We're going to draw a point at the origin. That's where 0, 0 is. And we will put the capital letter A to represent that point. Point B, 2, 4. We'll start at the origin. We'll go 2, 4, right 2, up 4. That puts us right here at point B. Let's plot the point C, 4, 2. Start at the origin, go right 4, go up 2, point C. -5, -1. We'll start at the origin, go left 5, go down 1, point D. -6, 3. Left 6, up 3, point E. 3, -3. Right 3, down 3, point F. Point G, 5, 0. So we go 5 to the right, and then 0 is our y coordinate. We don't go up, we don't go down, we stop right there. 0, -6, we don't go right, we don't go left, but we do go down 6. And that is point H. Sometimes we name points with letters. We can refer to a point as P or A. If we want to emphasize that point P has coordinates 2, -3, we can write it as P parentheses 2, -3, close parentheses. If there is a point whose coordinates we do not know, we can refer to it as XY or PXY, where X and Y are the unknown coordinates. So next to each point, write its coordinates. We look for point A in the graph, we find it, and then we say, how did we get there? If we started at the origin, how did we get there? We must do the right-left direction first, the X direction, and then the up-down. So starting at the origin, we would have had to have gone left 3, so that's -3, up 5, so that's a +5, and that's the coordinates of our point. Point B, what are its coordinates? 3, 4. Point C, -2, -1. Point D, 2, 0. Point E, 5, -3. Point F, 0, -4. Notice when graphing actual data, we may change the scale on the axes and/or indicate a break in an axis. The following points give the number of dogs sold by the doghouse for 4 consecutive years. Plot the points on a coordinate plane. Now, we've changed the scale. The vertical scale is 100, 200, 300, 400. The horizontal scale has this weird slash. Sometimes you'll see it in a symbol like that. It looks sort of like lightning there. That indicates there's a break. So even though the origin still represents the point 0, 0, we have a break in the numbers and we skip over until we get to 2005, 2006, 2007, 2008. So that symbol, either this lightning symbol or else a symbol with 2 slashes, means there's a break in the scale there. So we can plot these points. The first point is 2005, 351. So we go over to 2005 up to approximately 351. The next point is 2006, 479, somewhere in this neighborhood. 2007, 620. And 2008, 683. I'm not sure I've got those points in the right place, but you get the idea. The points sort of look like they're in a straight line. They sort of look linear. That's interesting. We like things that are linear. In the previous example, the first variable represented time, and the second variable represented sales. Time is independent, the independent variable. That's a very important concept, independent variable. And sales is the dependent variable. The sales of the dogs depends upon the time. How many dogs did we sell? I don't know. It depends on what year you're talking about. The first variable, the x variable, is the independent variable. We assign it to the horizontal axis. The second variable is the dependent variable. We assign it to the vertical axis. Determine which variable would be independent, the independent variable, and which variable would be the dependent variable. The weight of a package. How much does the package weigh versus the cost to mail the package? Would you say, how much does the package weigh? I don't know. It depends on how much it costs to mail it. Or would you say, how much does the package cost to mail? I don't know. It depends upon how much it weighs. It makes more sense to say the cost to mail it depends upon the weight of the package. So the weight of the package is independent. It comes first. You create a package, and then you take it to the post office, and how much you pay to mail it depends upon how much it weighs. The value of a car. Does the value of a car depend upon the time since the car was purchased, or does it make more sense to say the time since the car was purchased depends upon the value? No. I think the value of the car depends on how long you've owned it. So the independent variable is how long you've owned it, and how much it's worth depends upon how much time has passed since you purchased it. Does it make more sense to say the price of an item depends upon the monthly sales, or perhaps the monthly sales would depend upon the price? If it costs less, are people going to buy more of it? Yeah, I think the monthly sales will depend upon how much you're selling it for. If you can lower that price, you might be able to sell more. One of these variables is always independent, one is always dependent. The dosage of a medication, does that depend upon the weight of the patient, or does the weight of the patient depend upon the dosage? No, I think the weight is independent. That's what comes first. And then if you want to know how much medication to give the patient, that would depend upon how much they weigh. In examples 1 through 3, what story is the graph telling? Example 1. The following graph shows the cost to mail a package, depending on the package's weight in ounces. So what story is it telling here? Well, the story I'm getting is that if the package weighs between 0 and 24 ounces, it will cost $2 to mail it. Between 24 ounces and it looks like it's right around 64 ounces, between 24 and 64 ounces, it's going to weigh between $2 and $5, depending upon how much it weighs. Then, between 64 ounces and higher, it costs a flat rate of $5 to mail. So packages between 0 and 24 ounces cost $2. Packages greater than 64 ounces cost $5. And the packages between 24 and 64 ounces are between $2 and $5. That's one way you can state the story that it's telling. Example 2. A new car is purchased for $30,000. The value V of the car after T years is displayed on the following graph. So what's happening with this car? Well, it looks to me like you paid $30,000, and then for about, from the time you drive it off the lot until about a year and a half, the price of the car is going down steeply. You are losing value all the time. But once you hit a year and a half, up until about 7.5 years, then the value is decreasing slowly. I would say it's decreasing slowly here, and I would say it's decreasing steeply here. That's one way to describe it. And what's happening? Something really awful is happening right here. Right here at 7.5 years. At 7.5 years, your car is worth $0. It is not worth anything. So that's the story that graph is telling. The following graph shows the monthly sales of gasoline in thousands of gallons at Quick Stop, depending on the price per gallon. So what story is this telling? Well, between 0 and 1 gallon, at 0 gallons in fact, I would say that you can sell 20,000 gallons of gas. As the price goes up, remember you started at 0 and you're going up to $1. As the price goes up to $1, the price or the demand, the sales, it decreases, but it decreases slowly. It decreases slowly as the price changes from 0 to $1. Decreases slowly. When it hits $1 up until $3. So from here to here. There, the sales, what are they? They're about 17.5, 17,500 gallons. The sales, I'm going to use the word plateau. They stay about the same, right around 17,500. What happens at $3? Might even be like $3.25, but we're just kind of guesstimating here. So once you hit $3 or $3.25 or whatever it is, up until $5, the sales decline steeply. Now let's see if we can put this in English. You've got the price of gasoline. If it's $0, if you're giving it away for free, you're only going to be able to give away 20,000 gallons of gasoline. As the price goes up to $1, people still want it. You can still sell almost 20,000 gallons. It goes down a little bit, the number of gallons you can sell, but not by much. Really, people are willing to buy the gas at about the same rate up until you get $3.25. When the price of gasoline reaches $3.25, then you have a sharp decline in the amount of gas that you can sell. And when, the most important point of all, when the gas costs $5, when you're trying to sell that gas for $5 a gallon, nobody wants it. It is $0. No one wants that gas at all. So from 0 up until about $3.25, people are still willing to buy a lot of gasoline. But once it hits $3.25, the demand for it, the number of gallons that you can sell, sharply declines. That's all for this section.